Hi. Today we are going to work through a proof that the area of a circle is equal to pi r squared. Now, what you should already know is you probably learned that the area of a circle is pi r squared in school, but you may have wondered why does it equal that. So that's what I'm going to show you today. Okay. So first let's start off with the circle. And let's put the circle on the coordinate plane. So let's draw some axes. Let's make this the x-axis and this the y-axis. So they continue on. Okay. So let's draw some. Okay. So this is the radius. It's of length r. So it's very important that the rest of the video that you remember r is the radius. So that is just x. And that's y. Okay, so you see it forms a right triangle. So there's a certain relationship between them because of the Pythagorean theorem, which states that a squared plus b squared equals c squared. And now we substitute them, and we get x squared plus y squared equals r squared. Now, let's form this into a function, because y is the dependent variable, so let's make it into the function y equals the square root of r squared minus x squared, and you can verify that that's the way to do it. Okay, now continuing on, what do we do with this? So what we want to find is this area, the area that's inside the circle. Now there's a way to do this. So what we can do is take the integral from negative r to r of that function we just did, r squared minus x squared dx. Okay, now what this indefinite integral will give us, the indefinite integral will not give us the area of the whole circle. It'll just give us the area of the top part, but we can multiply it by 2 to be able to get the area of the whole circle, because it's taking the indefinite integral. It takes the square root as just like the normal square root, not like the complex square root, like with a positive and negative value. But anyway, let's continue. So, what is the indefinite integral of this function right here? Okay, so let's write that. So I looked this up on Wolfram Alpha, which is an extremely good program for looking up mathematical facts and stuff. So you could check it out. The integral is 1/2 times the square root of r squared minus x squared plus r squared over 2 times the arcsine of x over r. Now, you may so now let's review. So remember the arcsine is just the inverse sine function. So that means that the arcsine of n equals theta. Where theta is an angle, where the sine of theta is equal to n. So it's kind of just taking the I should make the inverse. So it's kind of just taking the inverse. Okay, so let's give ourselves a bit more room. Okay, so now we need to plug in for the top value minus the bottom value. Oh yes, and we're just taking the area of this top section, and at the very end we'll multiply it by 2, so don't be confused why we suddenly multiply by 2 at the end. Okay, let's go down. So now let's plug in. Sorry, I'm not used to this program, so it's taking a bit of work. Okay, so let's plug in 1/2 times the square root of r squared minus, we plug in r for x, so it's minus r squared plus r squared over 2 times the inverse sine of r, so of r over r, because we plugged it in, and that's just going to cancel out to equal 1. And we can also cancel this out because r squared minus r squared is just equal to 0, and the square root of 0 is just 0 times 1/2, so we can cross that out. And okay, and now I'll continue this onto the next line, minus, put this in parentheses, what we're going to be subtracting, the square root of 1/2 times the square root of r squared minus, now let's plug a negative r for it, and the square root of any negative number is just its positive version squared, so minus r squared. And we're taking r to be a positive number because you really can't have a negative radius. So now continuing, we can do plus r squared over 2 times the inverse sine of negative r, because we're just plugging it in, over r, and that will cancel out to be -1. Oh yes, and also this will cancel out similar to before, so we can have that. So let's rewrite this in a neater fashion, since I may have confused you. Well, not very neat. So let's write this as r squared over 2 times the inverse sine. Oh yeah, and it can either be arc sine or inverse sine. They're just kind of interchangeable names for it. Of 1 minus r squared over 2 times the inverse sine of -1. Let's squeeze a 1 in there. Okay. So now, so good so far, but what's the inverse sine of 1 and -1? Okay, so first let's do 1. So what number has a sine of 1? Now let's look at the sine function, or let's look at the inverse sine function actually. So let me switch to a different color. So the inverse sine function looks something like this. It's not really a function because, but we'll just consider it one. Okay, so let's see. When we take it as 1, we have the x. When we have x equals 1, the y coordinate is equal to pi over 2. Okay, so now we can cross that out, and that's just pi over 2. And now what's the sign of -1? Okay, so let's move down to -1, And that over here is negative pi over 2. Okay, now let's cross this out. So now we have negative pi over 2, and you see, and now these negatives cancel out. So now let's rewrite this: r squared over 2 times pi over 2 plus r squared over 2 times pi over 2. Okay, so now now we can just multiply, so it's pi r squared over 4, and you can probably see where this is going, plus pi r squared over 4, which is just equal to pi r squared over 2. Okay, and now remember that we would multiply it by 2 to get the full, because this is only the area of the semicircle. So now multiply it by 2, and we get pi r squared, which is the formula for a circle. So there you go. So if you enjoyed this, please come see more of my videos that I'm going to be making about math and science and other stuff. And thanks for watching.